Network cables are very important, even though most users use wireless these days. But behind the network, there are cables. We often focus on the capabilities of our new laptop or our desktop computer, and when we connect these to the network, we naturally assume that everything will connect and work as expected. It's able to do that because we were able to put in the proper cables to be able to send that information across the network. These cables or fiber optics are the foundation of everything we send across this network. If you have bad cabling, then your applications are not going to work as expected. You have to plan and install the correct cabling for the type of network that you plan to use. Even our wireless networks have cable at some point. We may communicate wirelessly to the access point, but that access point has to be connected to the rest of the network over those network cables. A huge number of the cables that we use on our wired Ethernet networks are twisted pair copper cables. We refer to these as twisted pair because the individual wires inside of this cable are twisted together into these pairs. You can see the blue pair is twisted together, the green pair, the orange pair, and the brown pair. Each one of those wire pairs contains equal and opposite signals, so the information being sent over one part of that pair may be transmit plus. The other wire in that pair is transmit minus. The reason that these wires are twisted inside of this cable is that one side of that pair is constantly moving away from any interference or noise that may be in the environment around it. When that signal is received on the other side, that receiver is able to determine what the real signal should be and what the interference might be based on the differences in that signal that it's receiving on both of those wires. And if you look closely at the cable that you're using, you'll notice that each of those wire pairs is twisted at a different rate. The receiving side can compare all four of those wire pairs and see the differences in that interference across all of those pairs at the same time. And since there are differences in the twist rate, the receiving device can easily see where the interference might be and where the good signal might be inside of that cable. Different twisted pair cables may be constructed differently. There is a set of standards associated with these cables that determines the minimum capabilities for that particular twisted pair cable. Sometimes people will refer to a cable as having a particular speed. In reality, of course, the cable doesn't have a speed at all. The cable is just a bunch of copper that's sitting there on the desk. The signals that you send over the cable, however, certainly do have a speed, and that speed is determined by the signaling coding that's being sent over those individual wires. To be able to send those signals across the wire, we need to be using a minimum category of cable for the type of signal that we're transmitting. The minimum category of cable that should be used for a particular Ethernet standard is documented in the IEEE 802.3 standard document. Those IEEE documents tell us the minimum category of cable that is supported for a particular IEEE Ethernet standard. For example, if you're using gigabit Ethernet on your network, then you're probably using the 1000 base T standard that IEEE has created. And they've put into their standards document that if you plan to run 1000 base T as your Ethernet standard, you need to use a minimum of Category 5 cable. If you look at the outside of the cable, you'll see printed on the cable itself what category of cable this has been tested to. So if you're using 1000 base T, you need to make sure you're using a minimum of Category 5. The Category 5 standard has been deprecated, so if you're buying new cable, you'll probably find Category 5E. There were additional tests that were added to the qualification for Category 5 cable, and those additional tests mean that we need to label it with a slightly different name of Category 5E. The E is for enhanced. So if you have an older installation of wiring and it's Category 5, you can run 1000 base T over that Category 5 cable to a distance of 100 meters. If you're installing new Category 5 cable, you're probably installing Category 5E, and obviously it can also support 1000 base T to a distance of 100 meters. If you're running 10 gigabit speeds, then you may be running 10G base T, which is 10 gigabit Ethernet over unshielded twisted pair cable, and you would need a minimum of Category 6 cable. If you're using Category 6 cable that is unshielded, it can run for a distance of 55 meters. And if this Category 6 cable is shielded, It can run for a maximum of 100 meters. And if you're using category 6A, the A stands for augmented, then you can run that same 10 gigabit Ethernet network to a distance of 100 meters. If you're ever wondering what category of cable you should be using, you should always refer back to the IEEE standards. So if you're running a 10G base T network, you should look at the IEEE standards for that, and it will tell you the minimum category of cable that is supported for that specific Ethernet type. But of course, twisted pair cable is not the only type of copper cable you might find. Another common copper type is the coaxial cable. Coaxial, meaning two or more forms sharing a common axis. Coaxial. This is an inner conductor. This is where all of the signal goes on that wire conductor that's in the middle. And there's an outer shield that's commonly associated with this to protect the signals that are running on that internal wire conductor. You often see coax being used for a number of different purposes, but for networking, we commonly see this associated with cable modems or digital cable. Anytime you're running high-speed internet over those cable infrastructures, you're probably using a coaxial cable. In our discussion of categories of cable, we talked about unshielded TP and shielded TP, and the type of cable you would use would be dependent on the standards that you're using and how far that cable needs to go. Unshielded twisted pair we refer to as UTP. This is a cable that has no shielding at all, so there's no shielding around the outside of all four pair, and there's no shielding around each pair of cable either. Another style of twisted pair you might find is the shielded twisted pair, where a shield inside of the cable itself is used to help protect against interference. The shield can be around all four pair, so you can see here we have a shielded twisted pair where the shield is along the outside, but it could be that you're shielding each individual pair of wires within that wire sheath as well. If you look in the outside of the wire, it often will tell you what type of cable and what type of shielding is being used inside of the cable sheath. If you see abbreviations that say U, it's probably unshielded. An abbreviation of S refers to a braided shielding, and an abbreviation of F is referring to a foil shielding. If you see this printed on the outside of the cable, it will usually have that abbreviation specifying the shielding used for the overall cable. There will be a slash, there will be the abbreviation of what shielding is used for the individual pairs, and that ends with TP to specify that it is twisted pair. So if you're using a braided shielding around the entire cable and then you're using foil around each individual pair of the cable, then the abbreviation on the outside of the cable should show S over FTP. If you have a cable like this one that has foil around the outside of the cables and then no shielding for the individual pairs, then that is an F over UTP. Here's a cable where we can see the inside of the cable and the writing on the outside of the cable. You can see this is a category 7 cable and it has some text that says S over FTP. This means that all of the wires inside have a shield around them and there's foil on each pair of the cable. And if we look at this cable, we can see the shield around the outside, and we can see that each individual pair of wires does indeed have foil around each one of those pair. If you work for an organization that has multiple buildings next to each other, or you work in a campus of buildings, then you may run individual wires between one building and another. Some organizations will run this wire overhead, but it might be much simpler and perhaps protect the cable better if you were able to put it underground. There are specially made Ethernet cables that are direct burial STP cables. They're designed to be installed in the ground itself. These are usually waterproofed. They may have a gel inside the cable to help repel the water so that you can put it in the ground and not even have to use a conduit. These are usually shielded twisted pair cables, not only to help against interference, but we can also use that to help ground the cable. This also adds a bit of strength, especially if we're putting this cable in the ground without a conduit. Structurally, this looks very similar to a shielded Ethernet cable that you would use on the inside of a network. You have 4 different pairs of wires. We might also have a shield around all 4 of those pairs to help protect against interference. And because this is going outside, usually in a place where water might be, we often will put a waterproof gel on the inside of that to help protect the wires even more. There's also usually a wire that runs the entire length of the cable that's often used as an electrical ground. You'll sometimes hear this referred to as a drain wire. If you're in a commercial building and you look at the ceiling, you're probably not looking at the bottom of the roof. You're probably looking at the top of a drop ceiling, and there's additional things above that ceiling that you can't see. Above that drop ceiling might be some ductwork that is able to feed air into the rest of the building, and another set of ductwork that's able to take a return air supply and send it back to the air conditioning system. When the airspace above that drop ceiling is not circulating, then we refer to this as not having a plenum. In many commercial environments, there's often an air supply that is providing fresh air through a set of ductwork, but the return air is simply going into the large open airspace above the drop ceiling. In this case, we refer to that open area as plenum space. One of the concerns that we have and that we always have to plan for is fire. In these plenum environments, where you have all of this open space above the drop ceiling,
Makes it very easy for fire, smoke, and toxic fumes to be able to move freely from one part of the building to another. This means if you're putting network cables above that drop ceiling, we have to use a cable type that has been specifically built for a plenum. If you were to move those drop ceiling tiles out of the way, you'd probably see something like this, where there's a number of different cables and connections. Some of them are electrical, some of them are for the fire system, and others might be for the network runs from one part of the floor to another. A typical Ethernet cable that is not something designed for the plenum has a cable jacket that's commonly made of polyvinyl chloride, or PVC. If you're putting cables above the drop ceiling, then you're probably using a plenum-rated cable. This has been specifically designed to be a fire-rated type of cable jacket. That means that it is a fluorinated ethylene polymer, FEP, or a low-smoke polyvinyl chloride, or low-smoke PVC. These are functionally the same as any other type of Ethernet cable, but they may be a little more difficult to work with, because that type of cable jacket may not be as flexible as the other types of cables. And although we don't like to think about bad things happening inside of our building, we do have to plan for the worst-case scenario. And if you're designing a network where you're putting these cables above a drop ceiling, you may want to make sure that you're using a plenum-rated cable and ensure to follow the standard.